All right, so we have another exciting talk for you. Thank you all for coming in and participate. Once again, today we have Kai Lu, who is coming to talk to you about uncovering the hidden dangers of 3D models in Microsoft 365. I am hoping that he is not uncovering all of them. It will help me with my job, but I am still hoping that he doesn't. All right, so without further ado, Kai Lu.
Yeah, thank you, Brett.
Thank you.
Hello, everyone. Thank you for coming here. I'm honored to be here to present my talk on covering the hidden dangers of 3D models in Microsoft 365. It's a journey of discovering 110 plus vulnerabilities in the SketchUp file format in the Office 3D component. Yeah, my name is Kai Lu. I'm a senior principal security researcher at Zscaler. This is today's agenda of my talk. First, please allow me to introduce myself briefly, and next I'm going to talk about the background of my research on SketchUp file in the Office, and the next one, I would like to give you an introduction to the 3D models in Microsoft 365. And next, we will move on to the main part of today's talk. I will talk about how to reverse engineer the Office 3D component and the SketchUp file format. And after that, I'm going to talk about how many vulnerabilities were discovered in. And in this section, security bypass will be discussed. And finally, I will wrap up with the final thoughts and the conclusion. In this section, I will highlight key takeaways from my talk. Okay, let's get started. My name is Kai Lu, senior principal security researcher at Zscaler. I mainly focus on vulnerability research, fuzzing, reverse engineering, and malware analysis. I'm interested in any low-level security. And until now, I discovered more than 150 vulnerabilities in products from Microsoft, Apple, Google, and Adobe. And additionally, I was a speaker at BlueHat USA 2018 Arsenal. Additionally, I was ranked top 1 on MSRC 2023 Q1 Security Researcher Leaderboard of Microsoft. Okay, this is the background. So when it comes to background, at the end of last December, I noticed that Lydia published 4 vulnerability advisories about Microsoft Office SketchUp files. So that was the first observed SketchUp file parsing vulnerability in Microsoft Office. So that discovery inspired me to take a dive into the component responsible for parsing a SketchUp file in the Office. And the SKP is a proprietary file format created by SketchUp software, mainly for 3D modeling and design. So inside a SketchUp file, you find all necessary information to create and render 3D models, like geometry, textures, materials, and more. So this format began back in 2000, which was first developed by Last Software. And then Google bought it in 2006. And then the Tribal Navigation took over in 2012. Okay, let's move on to the introduction to 3D models. So within Microsoft 365 apps, there is a total of 7 supported 3D formats. As you can see, the SketchUp file format was newly added last year. So other 3D formats have been supported for many years. And here's the timeline for the Microsoft. In June 2022, Microsoft announced the Office apps for Mac and Windows supported the insertion of SketchUp files. So this feature was available in Word, Excel, PowerPoint, and Outlook. So how it works in Microsoft 365? So it just it's easy to add a SketchUp file into in Office creations. Just in the menu, insert, and go to 3D models. Then go to this device and choose your SketchUp files and insert it. As I mentioned before, this feature was available to Office in set versions in June 2022, and several months later, this feature was made available in release version, and just 1 year later, Microsoft disabled the feature. In June 2023. Okay, let's talk about how to reverse engineer the Office 3D component. The dynamic library MSOSPECTRE is the Office 3D component. Which is responsible for file formats in Microsoft 365 apps. So my SketchUp vulnerability research was conducted in this version, so which was released in January this year. And after you drag the 3D component library into Adapro, you will see a bunch of functions which is prefixed with SU, which are the SketchUp APIs. And you can see the function the import asset 3D. It's a core function of parsing SketchUp files. Let's get into this function. On the right side is the pseudocode for the function import to asset 3D. I removed some trivial code in this screenshot, and so this function could call a series of SketchUp APIs and some wrappers. So as demonstrated below, so the function as you initialize was called, and next the function as you model create a buffer from buffer with sisters was called to, and another two wrapper functions like count entities and export entities. Right here, I want to plan to discuss each sketch IPS. So due to the one by one due to the limited time. So let's move on to the. And here is the wrapper function count entities. It also calls a bunch of SketchUp APIs and also called itself and it also calls another wrapper function count component instance. And next, this is the next wrapper function, import entities. Yeah. Let's quick go through another. This is another wrapper function, import component instance. Here's the wrapper function, import faces. And this is the function get material. Yeah, it will call to another wrapper function get texture ID and get texture. Let's look at this is get texture ID wrapper function. Here is the wrapper function get text. The last one, the last wrapper function is add faces geometry. Yeah. So, all right. Yeah. Yeah. With the help of reverse engineer, we have successfully analyzed all the relevant functions involved in parsing SketchUp files within the Office 3D component. As you can see, Microsoft used a series of SketchUp CAPS to implement the functionality of parsing SketchUp files. So yeah, fortunately, SketchUp provides SketchUp SDK and detailed online CAPS documentation, which contains all functions and data structures. So yeah, it's really helpful in creation and refinement of our fuzzing harness. So these are all data structures you will find in the SketchUp CAPS. And next, I'd like to talk about some key functions in the SketchUp CAPS. The first one is the SU initialize. Yeah, this function must be called before calling any other APS. And the second one is the SU terminate. Yeah, which must be called when done using API functions. The most important one is the function SU model create from buffer with status. So this function is used to create a model from a SketchUp file buffer. So it takes 4 parameters. The second one and the third one are in parameters, and the first one and the fourth one are out parameters. Okay, we have detailed the process of reverse engineer the Office 3D component and to extract the parsing logic for SketchUp file in Microsoft 365 apps. So now it's time to explore how to develop a harness for fuzzing the Office 3D component. On the right side, we have the outline of the harness source code. In this code, we declare various SketchUp APIs and implement a couple of wrappers as showcased during the reverse engineer process of the Office 3D component. Okay, here is the code snippet of the SketchUp harness. Yeah. The first step involves loading the Office 3D library using the load library API, and following that, it's essential to call SU initialize before using other SketchUp API functions. Once initialized, the fuzzme function is called. Finally, to wrap things up and ensure proper cleanup, the function SU terminate must be called. Yeah, here's the function fuzzme. Yeah, which implements the functionality found in the method import to SS3D in MSOSPECTRE dynamic library. A time to a demo. So in order to help you better grasp the harness inner workings, so let's play the demo for the. I like to give you a demo by sharing the entire source code. In the Visual Studio, we need to include the SketchUp SDK header file. Oh, this is the main function, and go to the follow me function. In the beginning of the source code, I declared the SketchUp APS. The entire source code is a little bit longer. It has around over 1,000 code of lines. And right here, right here we run the harness with a SketchUp sample. The time it takes to parse a SketchUp file within the harness, very depending on the data included in the SketchUp file. So. All right. As you can see, the harness works well. We have the fuzzy harness ready. Next step is setting up the fuzzer to fuzz the SketchUp harness. So the first I began by collecting thousands of samples of SketchUp files from several 3D warehouse websites, and secondly, in order to make the fuzzing process efficient, I narrowed down this collection to a smaller group of SketchUp files using the WinFL Python script, and while integrating with this integrating this harness into WinFL, we encountered a time issue. Despite this challenge, finally we adopted a demo file format fuzzer, which proved to be a workable solution. And this approach led to impressive delivery, and we uncovered 20 unique vulnerabilities in just 1 month through this, through fuzzing this harness. So, yeah, here is the fuzzing result. Yeah, as you can see, these findings include various types of vulnerabilities, such as user after free and user after heap buffer overflow, type confusion, and auto bound ret vulnerabilities. Okay, next let's move on to the section reverse engineer the SketchUp file format. Yeah, the SKP is a proprietary file format developed by SketchUp software. So through reverse engineering, we uncovered SketchUp files support two distinct data types: the MFC type and the VFF type. Yeah, in the Adapro, we found the function read model is used to read data from a SketchUp file. And as you can see, if a VFF header is present in the SketchUp file, it will call the function, the reader VFF read model to handle the VFF data type. Otherwise, it will call MFC read model function to handle the MFC data type. Yeah, here is the SketchUp file structure of the MFC data type. So as you can see, it starts with a SketchUp header with a GUID followed by a version map and other specific data. In the version map and this specific data section, you will see a sequence FF, FE, FF at the beginning, followed by a length field, that's 1 byte, and then a Unicode string. After the Unicode string, you will find the specific data. And next one is, let's look at the SketchUp file structure of the VFF data type. So it begins a SketchUp header, followed by a VFF header, and then a zip file. So this VFF header contains 13 bytes of data, and it begins with the magic number VFF, and then followed by the length field. Which the length field indicates the length of remaining VFF header, and the next 4 bytes are currently not identified. Maybe possibly serving the other specific purpose. So the VFF header ends with checksum field. I will talk about how the checksum is computed later. Okay, let's move on next slide. Okay, now let's see what's inside the zip file that we get from a SketchUp file with a VFF data type. So there's a lot of different things inside the zip file. You can see the 3D model, 3D data like model, styles, materials, and meta, etc. So one interesting part is the material folder, which contains an image. So processing an image file within the SketchUp file could be a potential attack surface. Okay, Okay, following is the one of the most interesting fund. So, as you can see, based on the stack backtrace, it indicates the data within the SketchUp file is the MFC type. So the crash occurred during the parsing of a JPEG file. So so what makes this finding even more fascinating is that another third-party library, FreeImage, is used to parse the image file contained within the SketchUp files. So the FreeImage supports 30 different image file formats. So this wide range of supported formats presents a significant attack surface for fuzzing. Yeah. Okay, next let's compare the normal SketchUp file to the minimized SketchUp POC file. Yeah, what we notice that is just one byte is changed, which is located within a JPEG image embedded in the material structure of the SketchUp file. So additionally, the 4 bytes before this image file data indicates its length. So. Yes, I seen in the stack backtrace before, the function create a BMP from memory calls a series of free image APIs. These APIs are made to parse the image embedded within a SketchUp file. And here is the free image introduction. Free image is an open source library. Yeah, for a developer who want to provide popular graphics. Yeah, so like it supports like PNG, BMP, JPEG, TIFF, and others. So the most released version of this library, was made available in 2018, just 5 years ago. So. And next, I developed a fuzzing harness for fuzzing free image by implementing the function create a BMP from memory. Okay, let's play the demo. This is the entire source code of the free image harness. This harness is rather simple, compared to the SketchUp harness. Yeah. Okay, all right. Yeah, as I mentioned before, FreeImage has a capability to handle 30 different types of image file formats. So what are these supported image file formats? Well, to find the answer, you can exploit a set of functions in Adapro that's responsible for setting up and working with these 30 supported image file format. Yeah. Okay. So once we have the harness ready, the next is to set up a fuzzer to fuzz the free image harness. So here are the steps I followed. First, I collected thousands of samples of 30 different image file formats. Second, in order to make the fuzzing more efficient, I minimize the collected samples for each image format. So, and then I integrated the free image harness into WinFL. Yeah, unlike our experience, previous experience with SketchUp harness, this time this harness functioned perfectly. And finally, finally we discovered 97 unique vulnerabilities in just 2 months. Okay, next, let's talk about how to reproduce these vulnerabilities in the Microsoft 365 apps. First, we determine the size of the crafted image file, and next, we replace the image file in the SketchUp template file with the crafted image file. And finally, we just need to make a modification to the size field. The size field just is located before the image file data. Okay, let's move on to the section vulnerability discovery. Finally, these two harnesses discovered 117 unique vulnerabilities in just 3 months. So Microsoft assigned 2 CV numbers for all of the vulnerabilities. The first CV was released in April, and the CVE 2023-29344 was released in May. This is the comprehensive list of vulnerability, 117 in all. So this includes 20 vulnerabilities that were identified through the SketchUp harness, and an additional 97 vulnerabilities discovered through the free image harness. As I mentioned before, the patch for CVE 2023-29344 was released in May and fixed all vulnerabilities mentioned before. So here is the patch version. So at that time, I was intrigued by how Microsoft managed to resolve a multitude of vulnerabilities within just 1 month. So now let's explore the details of this patch. Here is the patch code before patch and the after patch. So, and let's compare the function read model before and after patch. As you can see, the patch introduced some code changes to disable support of SketchUp files with MFC type. Because all vulnerabilities in free image were reported to Microsoft through the MFC type of the SketchUp file. So that's why Microsoft fixed these vulnerabilities just by disabling support of the SketchUp file with MFC type. So, but it didn't fix the underlying issues in the free image. So as you can see, the patch is slabby because vulnerability in the free image library could still be triggered using SketchUp file with VFF type. Also, below okay. Next, let's talk about how to bypass the patch for CVE 2023-29344. So below is a POC crafting template for a SketchUp file using the VFF data type. So which contains a SketchUp header, a VFF header, and an embedded zip file. So all data related to SketchUp 3D models are stored within a zip file. Okay, next, let's proceed to extract the part of the zip file in a SketchUp file and analyze it using the zip template in 010 editor. The result of parsing shows an image stored within the material folder. Okay, next let's start to craft a new POC. First, we compressed the abnormal image file using the deflate algorithm, just using the Python script, and then we need to compute a new checksum for the uncompressed image data. Here we use you can use CLC2 or Windows built-in CLC utility, and finally we make some modification to several fields, such as FR CLC, FR compressed size, and FR uncompressed size, and FR data. Okay, next, and moving forward, so we still need to update the field the header offset for each directory entry. So additionally, we also need to update the field DCRC, decompressed size, and de-uncompressed in the structure zip directory entry. Yeah. So, and additionally, we also need to update the field ER directory offset in the structure zip and locator. So again, continue our progress. Once we made the necessary adjustments in the crafted zip file, next step is combine the SketchUp header, VFF header, and the modified zip file into a complete SketchUp file. So, however, there is one more crucial task we must handle. That is recalculating the checksum in the VFF header. So through reverse engineering, we found the SketchUp uses a specific algorithm to calculate this value. So I developed a C++ program to calculate this checksum. This program takes the checksum as input. It's a list of CRC values, which is a collection CRC field in the structure zip file record array. Yeah. So. Okay. Next, I am going to give you a demo for bypass patch for CV 2023-23-29344. Yeah, first let's test the POC on the patched version. Yeah, as you can see, a dialog popped up. Yeah. That means Microsoft mitigated this vulnerability. Next step, let's look at let's test the bypass POC on the patched version. This POC is a VFF data type, yeah, so to bypass the patch. As you can see, the crash occurred in the patched version. Finally, let's compare the to the stack backtrace for SketchUp with VFF and the MFC. Let's compare that, yeah. This is a stack backtrace, and as you can see, yeah, the root cause is same, yeah. Okay, so far we elaborated the steps of crafting the new POC to bypass CV 2023-29344. So with this approach, we reproduced 97 unique vulnerabilities in Microsoft 365 apps, updating to the patch. So Microsoft just assigned one CV number for this discovery of bypassing the patch. So this patch was released in June, and finally, Microsoft disabled the ability to insert SketchUp files in Office document, and yeah, the Microsoft didn't want to fix the all issues in the third-party library, so they just cut the attack surface. I'm still wondering if Microsoft has a timeline to bring the feature back sometime. So. And this SketchUp vulnerability research, we totally reported 214 cases to Microsoft. Yeah, which include uninitialized memory, information disclosure, user after free, stack buffer overflow, heap buffer overflow, type confusion, integer overflow, and etc. Yeah, here are the MSRC cases number. Yeah. So in the end of the section, vulnerability discovery, I'd like to give you a couple of case studies. This is the first case study. This is the SketchUp file parsing C vertex object user after free vulnerability. And the second one is the SketchUp file parsing TIFF image integer overflow vulnerability. As you can see, the crash occurred in the memory copy function. So the next one is the SketchUp file parsing uninitialized memory vulnerability. As you can see, this vulnerability is potential RCE. So, and the next one is the SketchUp file parsing BMP image auto bound write vulnerability. So the last one is the SketchUp file parsing picked image auto bound write vulnerability. As you can see, on the left side is the crash information for the SketchUp MFC data type, and the red one is the bypass stack backtrace. Okay, as we wrap up this talk, let's reflect on thoughts and conclusion. Throughout this presentation, I walked you through the process of reverse engineering of the Office 3D component. We've explored how to create two effective fuzzing harnesses, one for SketchUp and the other for free image. Yeah, these results have been remarkable. Yeah, and uncovered a significant number of vulnerabilities. So, and also, yeah, it does not appear the security testing was performed for the new feature of SketchUp in Microsoft 365 apps. So, yeah. And another takeaway from the talk, just sometimes take a dive into a patch for vulnerability, might yield surprising insights and help you uncover new vulnerabilities. Here's the reference. Okay, thank you. Thank you for listening. Yeah.